Hello guys, I want to put my TikTok account on course, and the reason why I opened my TikTok account is about helping in doing some calculus questions on OD, and that is the first order and the second order. Also any question on calculus, that is, we can include integration, differentiation, and many others. So we want to do this question on the separation of variables under ODE1, and we'll be doing a lot of questions in this account. So if you need any help in any question, you can ask in the comment section. So we can do this one first, such that you see whether it is helpful to you. And this one goes to those who are maybe doing their high courses, that is, maybe they are doing education, Bachelor of Education in Science, and they are doing mathematics. They get some difficulties, so I'm here, I can help when needed. So in that one, we have a question so that if y is equals to a at t is equal to 0, the solution of the differential equation dy dt is equals to omega into a squared minus y squared raised to power half, where a and omega are positive constants, can be written as y is equal to a cos omega t. So the first thing we must know is that we are given now what we are supposed to get. So in that case, we are supposed to get that y is equals to a, the cos of omega t. So you are given this kind of an equation, dy dt is equal to omega a squared minus y squared raised to power a half. So we can write this one, instead of raising it by power half, we can write it as dy dt is equals to omega, instead of now raising power half, is the same as saying the square root of a squared minus y squared. So in this case, remember, we are supposed to separate the variables, so it means that we must put the variables together. So the one with y, they are put together. So like now we can put dy all over, whereby we have a variable of y. So it means anything in the right hand side which is having a variable of y will be brought to where we have dy, and we must operate this one in a better way. So in that case, so we are going to, of course, take the variables of dt the other side, so we cross multiply dt, and also this side we multiply dt. So you are going to have dy is equal to omega, of course, the square root of a squared minus y squared, then dt. Remember, I said that anything which is having a variable of y must be put to the other variable of y, that is dy. So in that case, we divide both sides by the square root of a squared minus y squared, and also this side by the square root of a squared minus y squared. So that and that one we cancel out, so we remain with dy over the square root of a squared minus y squared is equal to omega dt. So you are going to realize that when you operate ODE equations, mostly it's going to take us to integrate, because remember, we need to get variable y. So it means for us to remove dy, it means we must integrate those two variables, that is the variables of dy and the variables of dt. So it means we integrate both sides because we have put the like terms together. So in that case, it means that we must integrate both. And you realize there's something you must realize, that it is not easy to operate the variables of dy, because you must know all the methods of integrating. So we have the separation method, we have the method of course, the by parts, the partial fraction, and many others. So it means for that one, you are going to apply one of the methods that is maybe by part separating, and also we can use also the partial and many others. But in that case, we can be able to operate the right hand side with a lot of ease. So first we operate what we can be able to operate with ease. So in that case, we are going to have the integral of dy over the square root of a squared minus y squared. We operate the one which is the right hand side. So this is the way we do integrate, which is obvious what we learned from high school. So in that case, we integrate this one. It's going to be omega, because omega is a constant, dt. So dt, when you integrate to dt, we are going to have what? T plus c, a constant. So in that case, the left hand side is we are going to think on what to use. In this case, we cannot use the partial method. We cannot use the by parts. So the only way we can use is substitution, and we must think, what can we do? What can we introduce in this case such that we can be able to operate this one? When we have the square root 1 over the square root of a squared minus y squared, in this case automatically we do introduce that. We say that let y to be equal to a, which is a constant, this constant, the sine of theta. So you are going to have, of course, we must also differentiate this y such that we get dy. So dy is going to be equal to a. When we differentiate sine, it becomes cos, so it's going to be cos theta d theta. So in that case, wherever we have dy, we put this. So we are going to have a cos of theta d theta all over the square root of a squared minus. So instead of y, so you are going to have this one, which is a sine of theta. Then you close the bracket, we have the square. So is equal to wt plus c, omega t plus c. So in that one, you're going to have integral of a cos of theta d theta all over a squared minus, of course we open this one, is going to be a squared, the sine of squared theta is equal to omega t plus c. So integral of a cos theta d theta all over, so we add the square root, remember that. So we have the square root a squared, so we factor out the a squared, inside we remain with 2 now, 1 minus the sine of squared theta, then is equal to omega t plus c. So you are going to have, in this case, but we know that from the trigonometric, of course, rules we know is that we know that 1 minus the sine of squared theta is the same as cos squared theta. So instead of putting now here 1 minus the sine squared theta, we are going to put cos squared theta. So you are going to have the integral of a cos of theta d theta all over the square root of a squared, the cos of squared theta is equal to omega t plus c. So you are going to have integral of a cos theta d theta all over the square root of a squared is a, and the square root of cos squared theta is cos theta is equal to omega t plus c. So this and that one will cancel because they are the same. We remain with integral of d theta is equals to omega t plus c. So but integrating d theta is going to remain theta only, is equal to omega t plus c. So now if we have that, then now we must get theta, because remember we need to have the variable of y. So there's a relationship of y and theta, which is y is equals to a, the sine of theta. So in this case, we need to know how can we get theta from here. So we put all over a such that we have the sine theta is equals to y all over a. So we want theta only. So we find the the sine inverse. So the sine inverse is going to be theta is equals to sine inverse of y all over a. So in that, so you are going to have theta is this one, so we substitute. Instead of having, now we are going to have the sine inverse of y all over a is equal to omega t plus c. But we realize that now in this one we need to get c, because we were given some terms that show that if y is equals to a, so y is a at t is 0, so it means we put the sine inverse of a all over a is equal to 0 times omega plus c. So the sine of a all over a is the sine inverse, of course, of 1 is equals to, this one becomes 0, then c, and the sine inverse of 1 is, it can be 90. Yeah, so we can put our c is 90. That is the sine inverse. So in that case, then we go back, we substitute. So we had the sine inverse of y all over a is equal to now omega t plus 90. So we want to remain with y all over a. So if we want to remain with y all over a, we treat this one as an angle, such that we are going to have y all over a is equal to the sine of omega t plus 90. Now from here you realize that we have a rule here whereby we know that from trigonometric rules, sine of x plus y is equal to the sine of x cos of y plus the sine of y cos of x. So instead now of writing this one this way, so we can write it using this method, such that our x is omega t and our y is 90. So we are going to write this one as y all over a is equal to the sine of omega t plus cos of 90 plus the cos of omega t sine of 90. So in that case, y all over a is equal to cos of 90 is 0, so it means it's 0 plus, and the sine of 90 is 1, so 1 times cos of omega t. So you are going to have y all over a is equal to this cos of omega t. So we want to remain with y, so we multiply both sides by a and this side by a. So we remain with y is equals to a cos of omega t, and this is what we were asked to show. And with that one, that is how we can operate that differential equation. If you find this video helpful, you can also ask for more questions. Thank you for watching.